RoboDK can be used for robot calibration as well as robot simulation and offline programming. Robot calibration can be accomplished using a measurement system such as a laser tracker or a stereo camera. This video shows how to calibrate an industrial robot using the stereo camera measurement system from Creaform, also known as a portable CMM. Once the robot is calibrated, RoboDK can be used to easily generate accurate robot programs. To prepare the setup, retroreflective targets must be attached to the robot tool and base to be able to measure the tool position properly. In the computer, we can then select the targets that correspond to the base frame. We can also select the targets that are attached to the tool and specify that we want to track them as one object. The optical probe can be used to measure geometrical shapes and place the base reference frame and the tool frame at a specific position of the object. For example, we can place the tool frame at the tip of a reference spindle. To do so, we must probe geometrical features that will define the tool axis and position. In this case, the geometry used as a reference is the cylindrical shape and the cone of the reference tool. When we're done probing, we can move the reference of the tool with respect to the geometry. Once the tool reference has been identified, we can move the measurement device to make sure that the robot is inside the measurement workspace. The position of the measurement device is updated in real time in RoboDK. We can also move the robot from RoboDK to make sure that the measurements can be taken without any problems. Once the setup is ready, robot calibration can be accomplished in 4 simple steps and less than 20 minutes. The robot movements and measurements are synchronized by RoboDK. The first step requires measuring 6 configurations to calibrate the base reference. If some targets are not visible by the measurement device, we can move the stereo camera to extend the workspace. Moving the measurement device does not have an impact on the measurements because the tool is measured with respect to the base frame. RoboDK will warn the user if the measurements are not taken properly. The second step requires measuring 7 configurations to calibrate the tool frame. The third step requires measuring 60 configurations throughout the robot workspace. These measurements are used to calibrate the robot. The calibration measurements can be generated automatically by a script that uses the RoboDK API. We can specify the robot workspace in the Cartesian space and the joint space. The script randomly generates configurations within the allowed constraints. An estimate of the robot accuracy will be provided after the robot calibration is completed. The fourth step is optional, and it allows validating the accuracy of the robot by measuring additional configurations. Once the robot calibration is completed, we obtain some statistics showing the robot errors before and after calibration. Robot calibration can be improved by a factor of 2 to 10. The accuracy of the robot can be used to better calibrate the tools and reference frames. Additionally, RoboGK can also be used to do ISO performance tests as well as ball bar tests to check the performance of the robot.